left off with talking about area. And we talked about the basic area formulas. So again, here we ended, to my recollection, we ended with this figure being made up of two basic figures, a square and a circle. While this is not a complete circle, it is a semicircle. So we still have to take into consideration the formula for the area of a circle. So now, again, the diagram that they gave us only originally gave us the one measure. However, in that instance, when they only give you one measure, it is understood that the other sides have the same measure. So that's why we wrote in, this is 6 feet and this is 6 feet. So that let us know that we have a square versus us having a rectangle. So now, again, we are going to then take the area of the square and we're going to subtract. Now, again, we don't have the whole circle. So then we're going to subtract half the area of a circle, and we're going to get the area of our shape. Make sense? Yes, no, maybe? We just going to follow for the moment. That's okay. All right, so now again, anybody, what's the recall? What's the area, the formula for the area of a square? Got to bring pencil and paper because you're going to have to write stuff down, good people. That's all right. I'll refresh your memory. So because a square has 4 equal sides, we're going to say the side times the side. So side squared. But for us, the measure of the side is 6. So that's going to be 6 squared minus, anybody remember the formula for the area of a circle? We talked about it yesterday, people who were here. Ooh. Pi.
Area, pi times r squared.
Yep, exactly. But again, since our picture is a semicircle, we're going to take half of it because we only need half of the circle. Okay? We only have half of the circle. So we only need half of the circle. We only need the area for half of a circle. All right. So now, again, we know pi is what value? What's the value of pi? Ooh. So pi is 3.14. And they told us that our radius from the problem was 4. So all that was a substitution. Okay? This was the formula. Again, we only have half of a circle. So we are taking half of the area of a circle. Again, half. Pi is 3.14, and we're multiplying that times the radius, which is 4 squared. So now, let's do some math, good people. So what's 6 times 6? Oh, Mike. Thank you. Yep. 36. Ooh. Minus All right, now we got 1/2 outside. So we got 3.14 times, what's 4 squared? Meadow, you joined me twice. I have you twice, boo. Wait,
Yeah.
oh, okay. All right, so what's 4 squared? I'm sorry. Okay.
16.
Thank you. All right, 16 now. Calculators. 1/2 of 3.14 times 16. What you get? Now I'm going to play a little creativity right here. I'm going to take off that other half of the circle. That's what our picture looked like originally. They just had us hanging out there. All right, so now, since I only have a little bit of space, I'm going to bring this problem over here. So we got 36 minus, and then what's 3.14 times 16 divided by 2? Let's see. Can I have the problem up there?
25.12.
Thank you. Minus 25.12. And then what is 36? Minus 25.12.
$10.88.
I was going to say 10.88. Okay. Yep. So 10.88. And the measurement is feet squared. Now, that's extreme. But for those of you who are going to some form of post-secondary ed, you might see this, especially if you're going into any of the trades, carpentry, welding, maybe if you're going into masonry where you're going to lay bricks, build steps, build walls and stuff like that. Interior designers, because that could be the shape of a room. That could be the shape of a piece of furniture that you're trying to get into a room. Okay? So, and even in your own house, when you buying furniture, what if this is the shape of the sectional that you want to put in your living room? You need to figure out how much space it's going to cover, it's going to need to see if it'll fit in your room. You ever go into somebody's house and it seems like all the furniture is just all crunched together? Well, that could be because they didn't do the math and they didn't figure out the size of the furniture versus the size of the room. So that's where you would use it in real life. So we are going to just, get into a little practice of doing finding area. So here is what we're gonna do. Bam. All right, so again, we know that area is the amount of space contained inside a closed, and it's measured in square units. So can you all see my screen?
Yeah.
Okay. All right, so it's measured in square units. So remember, you always have to include the units so that people will know how big or small something is. Okay? So again, measured in square units just means that it will always be raised to the second power. Okay? That's how you, again, if it's a multiple choice test and you are finding area, If the unit of measure does not say square, that's one of the things right there that knocks the answer out the box. All right, so looking at this problem, find the area. I'm gonna give you a couple minutes. I have 11:51, so I'm going to give you about 3 minutes, and of course you're going to tell me how you did it, what you did, and I'm going to draw it up here so that in your explanation I can also provide a visual. But this is a problem we're going to do, which is why I haven't erased it. That's our last find the area. Okay. Let's draw the picture. Here is the shape. Okay. And they told us this was 6 centimeters. This was 4 centimeters. This was 2 centimeters. And this was 3 centimeters. All right, so now if this picture, let's say this picture is the path from your garage to your front door. This is what it looks like. And you want to cover it with rocks. You know, you want to make a cool little path. You're going to buy you some bricks. You're going to hook it up. Okay. But they sell the bricks in bags, and they tell you about the area of how much each bag will cover. Okay, so that's what you're trying to figure out. How many bags of these bricks, these rocks, are you going to have to buy so that it covers your walkway? And again, like I said, from your garage.
Yo, miss.
Yes, dear.
What's this called? I just got in the class late because I ain't have my computer. So
Okay.
Can you send me the joint?
Yeah.
Today?
Yeah, you want me to send you the recording of the class?
Yeah.
Okay. All right.
All right, set it down.
All right. So, attendance wise, I got Nasir, Shanice, Waddell, Christina, Ike, Liv, Meadow, and Tehran. Did I miss anybody so far? Okay. All right, so talk to me, good people. What did you do? How did you approach finding the area of this shape? Think about what we talked about yesterday. It is irregular. So when it's irregular, again, we know the basic formulas. We know the area of a square is the side times the side. We know the area of a rectangle is the length times the width. We know the area of a triangle is 1/2 the base times the height. And we know the area of a circle is pi times the radius squared. So which of those basic formulas will help us here? What shapes do you see? Cut it up. Okay, well, while you all are thinking, I'll go get some water. I'll be right back. I need somebody to talk to me. Well, can you at least tell me what two shapes you could possibly see out of this shape, out of this irregular shape? What basic shapes do you see or can you create?
A rectangle and a square.
Mm-hmm.
Yeah.
A rectangle and a square. All right, so where you want me to draw the line? How did you draw? You went across, you came across from 2, cut it off there. Where's your line to make the square and the rectangle? So you made your line here. Is that what you did? You made your line across here?
Yeah.
Okay. All right. So now, okay. So now that we cut the shape here, we now have to figure out what is the measurement of this line that we drew. So how can we figure that out? How can we figure out a line, the measure of the line that cuts here? What should it total? And how do you know? So if this side is 3 centimeters, we already know this is also 3 centimeters. But the question is, how long is this line here? Because we drew it people, the partner up here. How long is that line? I'm going to switch you back to me for a moment. All right, so this is what we have. We drew the line here. Again, this is 3 centimeters. This is 3 centimeters. My question to you is, how long is this blue line? Because we can't find the area of this space if we don't know to measure this line. Can we find
area of what, Miss Hicks?
How can we find the area of this bottom piece? What's the measure of this?
3 times 2, 6.
This piece is 6, or the whole thing is 6?
That piece.
This piece? But this piece can't be 6 because this whole thing is 6. And those two aren't the same length. So what does this piece have to be? Thinking on those same terms.
It has to be 4.
Exactly. Bam. It has to be 4. Because 4 centimeters plus 2 centimeters give you the whole side. That's what I'm talking about. Go, y'all, get busy. Okay, so now, let's find the area of this piece. It's a rectangle. So what's the length times the width? We want in here. What's the length? How long is it? Oh, wait. Somebody talking to me. Wait a minute. How's that? Yep. All right. Yep. A rectangle and a square. Yes. Square going to be on the bottom. All right. So what's the area of this space and the area of this space? So we got the rectangle plus the little rectangle. So what's the big rectangle? What's that area?
Is it 6 times 4?
Absolutely. Yep. This is 6 times 4. So what's 6 times 4?
24.
Thank ya. All right. Now what about the little piece? It's a rectangle too. What's length times width? What we doing?
Four times 3 is 12.
Okay. Yes. All right. So what is 24 plus 12?
Say it again.
24 plus 12.
36.
36. What's the unit of measure? (36 centimeters square). So again, you see how the original shape was broken into 2 smaller shapes. A rectangle going horizontally and a rectangle vertically. And you know it's a rectangle because the length and the width are different. Okay? But we took the area of the rectangle plus the area of the rectangle. So the length, 6 times 4, gave 24 here. Here, the length times the width, 4 times 3 gave 12. So the area of the entire shape is 36 centimeters squared. Remember, area is always measured in square meters. Okay? And again, remember, we will start talking about the topic surface areas on Thursday. So I'm getting you in the habit of finding areas and areas of irregular shapes. All right. So let's look at the second one and see what we have. All right. So we found this one to be 36 centimeters square because this shape is made up of 2 rectangles. All right. There's your next one. Basketball. It looks like a basketball court. Okay. So again, find the area of this entire shape. Your mindset. The first question you ask yourself, what two shapes created this one shape? And it is 12:06. I'm going to give you till 10 after, 11 after, about 4 or 5 minutes. Tell me again, first question, what two shapes made up this one shape? And then find the areas.
Are you drawing a different shape?
Is everybody finished with the shape that the first shape? Yes? No? Your silence? I told
Miss
you.
Hicks, is it a different shape?
Yeah, I'm getting ready to show you. It looks like a basketball court. So that's why I asked, is everybody finished with the first one?
Yeah.
Okay, cool. Then let me let me draw the next one. All right, so I'm gonna take you off of sharing my screen, bring you back to me. All right, so here's the shape. Like I said, the shape looks like a basketball court. And for all of you basketball players, I don't know if this is standard. Oh, I might need to draw bigger than that so I can put the numbers in. All right, so here we go. Daisy. Listen, Daisy was down here with me and we were friends. Now you come, now she want to show off. It's cool though, Daisy. I see you two-faced it. I see you two-faced it, Daisy, but it's all good. All right, so here is the shape. Again, it looks like a basketball court. So the question becomes, what two shapes made up this one shape? So we're looking for the area. And again, what two shapes made up this one shape?
Is it a rectangle and a circle?
A rectangle and a circle. So we got us a rectangle and we got us a circle. However, is it the whole circle?
No.
Right. That's right. So it's half a circle. So whenever we find the area of the circle, you know we're going to what? Have to divide it in half because we only have a half a circle. All right, so now let's talk about the measurements. So we know, again, the formula for a rectangle is the length times the width. But the formula for the area of a circle is pi times the radius squared. So do we have the measurements we need for the rectangle? Do we know the length and the width? How long, how wide?
$19 times 12.
19 times 12, absolutely. So 19 times 12, who knows? But we'll figure it out.
Is it 228?
Yes, it is. Thank you, darling. All right, so we got 228 there. So now Now let's talk about this circle. So we need to know the radius. If the diameter, which again, remember, this 12 feet will be the diameter, because if it was a circle, we had the other part coming this way, right? So if the diameter is 12, what's the radius? How does the radius and the diameter relate to each other?
It's half of the diameter.
Absolutely. So if the diameter is 12, what's the radius?
6.
Yes. Thank you, darlings. I love you. All right. So now we're going to do our magic. So for the circle now, we have, oh, I put them too close together. Let me put this down here. 2, 2, 8. All right. So we have 3.14 times 6 squared, and whatever we get, we're going to divide that by 2, because again, we don't want the whole circle, we want half the circle. So talk to me, math students. 3.14 times 6 squared, what you got? Because we need pi times the radius squared. Boop, boop, beep, two. Let me see too. Calculators in effect.
113.04.
Wait. 113.04. Did you divide it? That is after you divided it by 2?
No.
Oh, okay. So it'll be 113.4 divided by 2.
Yeah, and it's 56.52.
56.52. Okay. I don't have a lot of boards, so I'm gonna just do that. 56.52. And when we add them together, Daisy, did you eat it, Raina?
What are we adding together?
Add them together. We adding together 228 and 56.52.
$284.52.
Yes. What's the unit of measure? Feet squared, love.
Area?
Feet, the area, yep, is 284 and 52 hundredths feet. So it's a little more than 284 and a half. All right, last one is right here. Find the area of the shaded region. So work on it. Where's the granola in there?
I don't like it. We got vanilla yogurt. Told you, it's fine, man. You eat parfaits or structured jams?
They working on the problem.
Supposed to be coming here to do something. I don't remember. You should have bought
Again, for this one, we only need one basic formula. We only need the formula for the area of triangles. We almost done. Ladies and gentlemen, on Thursday, I'm going to tell you what your final project is going to be so that you can start thinking about it. It will not be a test. Create a story. Systems. Use.
How much rubber? Yeah, just, well, I don't know how much rubber is. Mommy likes strawberries.
Mm-hmm. Can you add some more blueberries though? All right. Let me see. I got everybody. Yes. Attendance. All right. Can I take down the basketball court so I can do the math for this triangle? We good? Okay. Again, you know, your silence means yes.
Miss, I think I got the answer.
Okay. All right. Wait.
Is it base times height divided by 2?
Yes. All right. So the formula you're going to need is 1/2 the base times the height. Absolutely. So that's the only formula you're going to need. All right. So tell me what you have. I'm going to call the inside triangle. I'm going to make that one purple. All right. What you got, babe?
Okay, I'm thinking about that here.
What do you propose, darling?
82.5.
That's your final answer?
Am I answering a big triangle?
I don't know. That's what I'm asking you. So we want the area of the shaded region, right? And it's equal to, what did you do? Tell me what you did, babe.
I multiplied 15 times 11 and I got
15 times 11. All right, wait a minute. So you got 15 times 11. And then
divided by 2.
Yep, divided by 2. All right. And what you get for that?
Hold on. 165.
165 divided by 2. You got 84.5 for that?
I got 82.5.
Oh, 82. All right. Check me, girl. All right. So that's the first one. I agree. So now she did the area of just the whole shaded triangle. All right. Now, what about that purple triangle? What you going to do with it?
I'm going to take it away.
Yes. Take away the area of the purple triangle. Yes. So, what's the area of the purple triangle? What's the formula you used?
5.8.
Go ahead. times what? What's the height? What's the height of the little one? I tried to make them all purple together. Somebody help her out.
8.
Thank you. And again, we're going to do what? Divide that by 2. So she took the base of the little triangle times the height of the triangle. 1/2 the base times the height. That's why she divided by 2.
Yeah,
So
and I got 23.2.
23.2 divided by 2.
For the little triangle.
Okay. And oh, that's your final?
Yeah.
Okay, 23.2. Wait a minute. So what's 8 times 8? 64. Put down your 4. Carry your 6. 46. All right, thank you. I just did the middle. All right, so she found the area of the larger triangle. Then she found the area of the smaller triangle. And just like the problem we started out the class with, she's doing a subtraction. So she had this burgundy triangle, and then she cut out the purple triangle. Yes, the math is beautiful. You go, girl. You go. All right, and when we subtract, 5 take away 2. 12 take away 3. 7 take away 2. Did you get 59.3?
Yeah.
Feet squared. Absolutely. So the area of just the shaded region is 59.3. Exactly. So you could have been making a fish pond and you into triangles, but you wanted people to be able to walk around the fish pond and see your fish. And this was the shape you created. So again, interior designers, you carpenters to be, these are the things that you might have to use in real life. All right, so ladies and gents, I thank you for coming. Remember, you do not have this class on Wednesdays. Okay?
Okay.
So you do not have math on Wednesdays. You will only have your morning class tomorrow. However, if you want to talk to me, feel free to. On Thursday, we are going to start our topic surface areas. Okay? And again, we are doing this piece, just finding area, because surface area, we're going to be finding several areas. Okay? So I wanted to make sure that you all had the foundation down, the foundation of finding the area of basic shapes. So I'll see you all on Thursday. Have a good tomorrow. And again, most things we're going to do in class, I'm going to tell you your final project on Thursday so you can start thinking about it as we go through the course. Okay? It's probably going to be a PowerPoint. That's your hint. All right. So thank you all for coming. And I will see you on Thursday, darlings.
Oh, wait, yo, don't forget to send me the joint. Just send me the class.
Yeah. I will. Okay. See you, darlings.
I see ya.